Thank you for coming. This is by far the nicest room I've ever presented in, so hope to not screw it up. Please ask questions as you have them, although the lights are also quite bright, so we'll see if the message actually makes it all the way to the front. Eventual consistency there. So, a little bit about Twitter. Twitter is obviously a very large platform for message passing, and it does many, many billions of requests per second in various different dimensions, actual streaming processing, and all kinds of big data work. I started out a little bit on the back end in doing database work, database and search, and I joined Twitter while working on Apache Cassandra a while back. Since then, I worked a little bit on some of Twitter's internal storage, custom storage, and I have now moved over to the build team in the last 9 to 10 months. So let's jump right in. In particular, I'm going to be talking about the source repository today, which is the direction that Twitter's code is headed in, a fully monolithic source repository. We have had 2 monorepos for going on 4-ish years, as you'll see. The general structure of this talk, which I skipped over, is that I'm going to talk a little bit about history, and I'm going to talk a little bit about how we do things now, because the lessons don't really sink in unless you explain the lessons of why we are where we are don't really sink in without the entire context. Forgot to mention, I've been at Twitter about 4.5 years, and so the very beginning of this history is a little bit fuzzy because I was not there for that portion of it, and so it was Scala lists that I was scraping. So numbers you've been reading while I was blabbing away. Twitter's primary monorepo is the source repo. It's fairly easy to say, oh, it's in source. It is source, because we build the repo from source, and that's one of our principles. But there are 5 to 10 million-ish lines of code in there, about 35% Scala and about 25% Java, and then JavaScript and some Python, and et cetera. There are other repos that contain a little bit more code, but the vast majority of Twitter's code is in source. And it's a Git repo. On disk, it's about 50 gigabytes. We love having a monorepo. We don't really love doing it with Git at the moment, so we'll see what happens there. We call everything targets. We want way more targets than we have, but we currently have tens of thousands of targets for those lines of code. And the JVM targets tend to average about 10 files per, which is across both Java and Scala. And I'll explain the target concept a little bit more later on. So the way we build software is fairly standard. For CI, we do use Jenkins, although we have kind of a multi-master setup, and the config is all in YAML, and we're trying to reduce the number of jobs we actually have. But when CI jobs run, if they have to build a large fraction of the source repo, they end up using something called Iron, which is a distributed Git-aware Mesos framework. And so there are many thousands of Iron instances. If I run, I'll talk about that later, but if I run a sandbox to test a change, and it manages to affect the entire repo, I might get up to 400 workers working on it in parallel, which actually brings the build time down to a reasonable, manageable size, despite building everything from source, on the 15 to 30 minute range for changes that touch the entire repo. And so Iron handles partitioning and executing commands at particular SHAs. So in CI, again, we have, of course, some Python code that wraps around our build tool Pants. And I don't know when I actually described Pants. My slides are a little out of order. But Pants is our build tool. Users don't typically have to retry their tests multiple times. You hate non-deterministic tests, so hopefully it's only CI that is detecting non-determinism. And this test retry is porcelain around Pants that runs in CI. And then Pants has a build cache, which I believe I will also discuss later. Immediately. So the build cache is a distributed cache of targets, of artifacts for pants targets. It does input-only hashing, which means we hash only the source files, which has some upsides. You can fetch all of everything immediately out of the cache. So you're always network bound for building. But the downside is that you need to have determinism. So the first macro that puts in a rand call is going to be interesting. But the performance of the build cache is very good. So most of the time when you are compiling something, it actually is fetched. And incremental compiles are what we focus on optimizing instead. So how a change flows through the system. Now I discuss pants. So locally, pants is our build tool. But at the same time, IntelliJ IDEA, I should say remotely, pants is our build tool. But the majority of usage locally is actually via IntelliJ. So it's great to see those guys here. We have about 60% usage of IntelliJ for local incremental compiles, to the point where we actually wrote a plugin for IntelliJ that is build graph aware and avoids having to do this project generation that we were doing for a long time and which was kind of fragile. And then anyone who isn't building directly with IntelliJ on their local machine is doing it with pants directly. For anyone, and honestly, it deserves a whole bunch more slides in here. Pants is in the same history, same ancestry as Google's Blaze, which became Bazel, and Facebook's Buck. They all focus on targets, really small units of work, the absolute minimum amount of code, or I guess I should say configuration, absolute minimum amount of configuration to define a target, because the goal is to have the most fine-grained targets you possibly can. Anytime I can more specifically depend on something, the better off you are, rather than lumping 1,000 unrelated things into one target. We would encourage small targets. So Pants does that. It was initially built at Twitter. It's open source now, and it's contributed to by Square and Foursquare, and a few other companies are coming on slowly. But it supports Java, Scala, Python, C and C++, and JavaScript hopefully will have to come fairly soon. So off topic. The local compile has finished, and you've decided that you want to test it more completely. Or you're in a core library, and your change is going to be affecting many other targets, not worth doing locally. Unlike Google, this is currently an explicit step for us. I was working locally, and now I'd like to do something remotely because I know it's going to take a while. And so we have this git review sandbox command, which submits a CI job, and then in parallel builds all change targets. And change targets is just based on the branch delta. And this runs atop the CI infrastructure. There's another thing that you can use to call iron directly, but usually for a particular target, but usually if you want, so for example, if you wanted to invert it and you wanted to run a particular target 4,000 times in parallel, you could call iron directly, but if you wanted instead to test 4,000 targets once each, then you'd use sandbox. And then once you've tested it, both locally and remotely, it goes into review, fairly standard. We use review board. And we have owners and groups files. So in a monorepo, because you're not project-centric, you're target-centric, the idea of project owners is fuzzier. And so instead, you just have directory owners. Directory owners and groups. And groups are the subjects, the targets, the destinations of your reviews. It's essentially who gets mailed. And owners are the people who need to ship some code, to ship it some code before it can be submitted. And submitting goes through a queue. It does almost exactly the same steps as the sandbox, and does the remote incremental compile based on the delta in the branch. Sandbox and submit queue both populate the build cache. Because the build cache is based on the hashes of the sources, it's not based on the Git SHA per se, which is important because we do squash merges. So the hashes of these sources, which again is also a SHA, confusingly, is the cache key for which you look up or store in the build cache. So if you sandbox and then immediately submit queue afterward, your sandbox will have populated the remote build cache, and your submit queue will then be significantly faster. So anyway, your submit queue then will merge to master when you've succeeded. Post-submit, because everything has gone through submit queue, the cache is already populated. And so the post-submit it's a full build, does no delta checking. Launched every 15 minutes, but there are usually 2 or 3 running concurrently. Okay. There's one more thing after life of a change, which is the change is now in master. Somebody who's pulling down the latest copy of master should hit the build cache because, again, submit queue populated it, and then the post-submit build, which might be running concurrently, is going to consume that and, I guess, fill in any gaps. The hit rate's very good, though, above 98%. And that's even including incremental compiles, because people are editing code and constantly compiling it, which each of those probably, hopefully, is not redundant work and is going to miss the build cache. Okay, so I now have a very long section of history of Scala, now that I've talked a little bit about how we do things currently. Mixed in will be more about how we do things currently, just mixed into whatever portions are relevant teaching moments. But slides that are historical have the rewind symbol on the bottom right. So the history is broken up into 5 themes, and they're colored. I hope nobody's colorblind. I apologize. I still haven't managed to edit the font for this. Red, no one will forget, that's the Scala core. Purple is tooling. Yellow is libraries. Green is conventions. And blue is usage. So if we go way back, Scala 1.0 was released in January 2004. Twitter didn't exist yet, so there's not much to say there. I did remember looking at it briefly during this phase, playing around in the REPL, didn't really get too involved. Fast forward, Scala 2.0. Martin is better equipped to talk about that period than I am. Scala 2.0 happened to coincide with the foundation of Twitter, so that's interesting, same month. It was fate. The 2.7 period, though, is when Twitter really started getting involved in Scala for the first time. And as many people have probably already heard, that was because breaking up a monolith into microservices, or just services, as we called them back in the day. So Scala 2.7 was released in December 2009. A lot of these are nearly verbatim from internal email. But the very first email to Scala Cafe, the list internally, was, why isn't Stream lazy? Then you scroll down a little bit and you see, oh, post-mortem, do not use immutable hash maps with highly concurrent access. I'm not sure why, but it was probably something to do with field visibility or who knows what. And then, somebody else asked, what's the easiest way to shuffle a list buffer? You'll notice that all of these were fixed in 2.8 and going on forward, so it was definitely necessary. But a lot of the early issues were around collections, and it's kind of drastic to see the before and after of the upgrade. Also in that early period, a guy named Alex Payne, who was the API head at Twitter and was one of the 2 or 3 core people responsible for making Scala at Twitter happen, he gave a very good pitch for Scala at our developer conference. And I think that spread around the world and did a lot of good for the community, which was great. I certainly looked at it before starting at Twitter. Also in that same period, ComTwitter util was created, and ComTwitter util future and try were introduced. And this is kind of this is kind of the symbolic birth of finagle. How many people are finagle users? Cool, excellent. Finagle is still going very, very, very strong in Twitter. One of the earliest things introduced and one of the most long-lasting. So, but also around that same time, we started to use Scala as configuration based on a very well motivated blog post. You know, why would you have factories? Just use Scala code. The problem, and who was it that talked about this? Oh yeah, Martin during the keynote mentioned early initializers, and not many hands went up. But if you're using Scala's configuration and you do any type of overrides, you are going to run into the need for early initializers, and you're going to hate yourself. But also you get logic and config. In any case, we're now using essentially just CLI args, which work fantastically well. Unix philosophy. Again, in that period, and actually very early on, there was a desire to be on source steps. Binary neps are painful, and to be honest, a few of the early people had already worked at Google and had seen source steps in action and kind of realized, well, this is useful. But unfortunately, they were kind of reinventing them within the tools that hadn't been designed for source steps. So we had a plugin, standard project and inline dependencies plugins. These are very early versions of SPT, and we used them for a fairly long time. But the gist was that you do version checks to try to enforce that a source version mostly matches the published version. But that trends toward the idea that for every Git commit, I need to do a release. Because if I'm like mostly on a version, or I'm on a snapshot of some version, I can't be sure I actually contain everything, and it's just this fuzzy mess. Also in that period, there were lots of back and forth on mailing lists related to breaking changes in API, because a library that lived in one little Git repo over here would make some API change that broke some other consumer down here. Or they'd break their only consumer, you know, like since it's possible, completely uncoordinated, to submit something over here that is backwards incompatible over here, you can have a single consumer and still break them. But usually it's like the 10th consumer that you forgot to check before you committed. So I'll go into that a little bit more. We also experienced some SPT compiler bugs. I did not manage to include what those were. Oops. The other thing about having lots of little Git repos is that you end up, in some cases, you don't want to deal with the binary dep diamond, and so instead you just kind of copy paste a function, like, oh, it can't hurt anything. I'll just copy paste this function from over here because it takes too long to like get it committed there and then do a release so that I consume it, and even worse if it's three libraries away. So yeah, you see a little bit of that, and people just like fessing up to it. Sorry guys, I copy pasted this because hopefully you'll fix it eventually. Okay, so let's go back to the present day. Instead, what we now do, this is our source layout. It is our capital S source layout as well. The ideal is to have all of our shared code categorized by language. So you've got at the root of the repo source Scala com Twitter, source Java com Twitter, source CPP com Twitter, etc. And you follow the 111 rule, which that is a link. It points to the pants build docs, but it's one target, one directory, one package. And by package, I mean language package. So if I have com Twitter util concurrent, com Twitter util concurrent should be a single pants package. It's not currently, but it should be. So the 111 guideline is probably more what it is. But the idea there is that if a package is reasonably factored, it again, would be reasonable to depend on that package to consume its public API. If it's not reasonably factored, when I depend on that package, I get stuff I didn't care about. I forgot to point out, anyone who's, if I weren't giving this talk, I would be in the talk about the .e linker, because it sort of solves this problem in the sense that you can do dead code elimination. But even if you've done dead code elimination, you still have already had to compile a whole bunch of stuff that you didn't need, right? So small targets are better. You might be able to eliminate them at runtime via the linker, but if you can avoid building them, you're better off. Shared code. Unshared code or open source projects, we're still kind of adapting our layout a little bit. From exactly this era, we had a lot of open source projects, and they were actually organized as projects, and we're sharing code. Anyway, long story short, you end up with a project name directory, and then you have things like configs, scripts, etc. But if I want to consume some shared library, I'm going to look for it in the per language categorized code. We isolate the third-party deps into a third-party directory, which patterned straight from Google. And the third-party directory is where the definitions of all of the versions are. So nowhere in source Scala or source Java or any of the project directories will you find a version mentioned. You know, versions are completely isolated because they're a thing that are related to binary deps. And internally, we have source deps. So they're isolated there. In theory, third party is completely consistent with itself. And so if I want to depend on, what's an example? Jackson. All code within third party should, in theory, use the same version of Jackson or, in the average case, compatible versions at least. And it's owned by a group, so owned, capital O, W-N-E-D, by a group that works to keep third-party consistent. When we need to consume cross-repo, we consume snapshots. So I publish the entire other Git repo atomically and then consume it here, which rules out all kinds of different diamond dependency issues that you can run into. So this interop section is with a grain of salt because I ran this and it was very surprising and I'm not sure I trust it yet. But what you should take away from this instead is that we have a lot of cross-language dependencies and we are very much a mixed environment. So at least in that regard, the fact that Java and Scala are interoperable is just absolutely critical to Scala. So nonetheless, we were very excited about all the things happening, and I'm sure that's not going anywhere. Okay, flashing back in history. So we had a lot of early usage of actors, but they all died out in usage in terms of com, Twitter, util, future instead. And my personal opinion is kind of the same way you don't want your devs using threads directly. Most of your devs using threads directly, you probably also don't want them using actors directly because actors imply state. And the vast majority of the time, we really just want people to like go use a cache. Use that cache right there. Don't store state in your process. There are definitely services where that's necessary, but for the vast majority of cases, we found that being stateless wins. Okay, so now we're finally getting into the Scala 2.8 error. In November 2010, we still hadn't updated. 2.8.1 was released. So 2.8x was a very ad hoc upgrade because, as I said, we were still at this period scattered out across a whole bunch of Git repos. Many of them open source, which was great. Many of them closed source as well. But it meant that the upgrade was very loosely coupled. And each repo probably had a update branch, and maybe it was named consistently with some other repo, but probably not, because it had been done by a different person. And then in January 2011, there was a stronger push. But because it wasn't coordinated in any particular way, there were still 2.7 bugs biting people long into the summer, into the spring of 2011. So very ad hoc, very free form. I mentioned the daemons in core libraries, but again, having all these Git repos meant that you had daemons because you really do want to encourage code sharing. You really do want to put things in the right place, but if that means that it's going to be 4 layers away in terms of libraries, you end up with strange runtime issues, essentially, when you compile. And then the binary incompatibilities, I think that was just a one-off thing where compatibility was broken. Also during this period was the beginning of the birdcage, which was one of the monorepos that took all of our open source projects and slurped them into a single Git repository. And the first commits there were in March. And I'll get into a little bit more about why monorepos. Simultaneously, a bunch of people who had come from Google were in the other repo, the science repo. And they were kind of already sold on the idea. They'd already gone to a shared, to a layout that encouraged sharing, was not project-centric. I'll come back to that. So at this point, ComTwitter util future was imported in 26% of Scala files, so it had really taken off. And by imported in, I mean had a literal import of ComTwitter util future. So very good adoption. And Kestrel, which was an early actor user, had mostly converted to futures at this point. Okay, so I've talked a lot about monorepos. So why monorepos? I'm going to repeat myself a little bit. But you end up eliminating binary dependency diamonds for the projects that you manage, and you want to encourage people to put code where it needs to live rather than copy-pasting it. It means that you can change multiple projects atomically in one commit. Very simple example is I change a library and I change the consumer. And generally it means you can shorten or remove deprecation cycles, because if somebody is committed enough to remove an API and remove all usages of the API, they can do it atomically without spending time to deprecate it. And again, it helps to eliminate what I've described a few times but not really called the topology problem, where if you think of, the distance away is proportional to the cost of making some change. If it's 6 libraries away, I will probably not even bother. And yet we want dependencies to be 6 libraries deep. So again, we avoid publishing in the common case. There's no need to recursively publish, because if something's 6 steps away, I need to publish 6 times. And a lot of companies pull this off. They do it via automation in CI to auto-publish. And maybe they put automation in place to detect whether semver has changed, and then they automatically do versions correctly, but probably they don't, and they give up and they do snapshot versioned. We just kind of skip that middleman, everything from source. The other thing about monorepos is, if you've done all that work in CI to do all this auto-publishing, and then also built auto-consuming, you might be able to pull off continuous cross-project, complete, holistic integration testing. But in source, we test every change against all of its dependencies before it's committed. And that helps to catch bugs drastically sooner, hopefully before they get committed in the first place. And also, you can Git bisect or bisect in general across continuous history, because we've all been in the situation where you bisect and you reach the bump from the major version bump, and you're like, oh shit, okay, so it's something in the major version bump, I'm totally screwed. Where instead, if you have the complete history, you see individual changes in libraries that you consume, which is really helpful for those libraries. And so on that note, the downsides of having a monorepo, you lose one evolutionary strategy, which is open source projects, when they do a major version bump, they are allowed to say, well, if you don't update on your own, you're screwed. I'm cutting and running. I'm completely abandoning this API. There is no ability to remove a deprecated API until all the consumers are gone. And so that means that you have to have a very good focus on killing dead code. and kind of maintenance, gardening, garden bench for Bill Venners. But you have to garden the code base and make sure that you don't have code that is just not pulling its own weight anymore. And also, another downside is service owners are frequently the ones doing the bisect when something breaks. As I said, some library changed something, and I can figure out precisely what it was, and they'll thank me because I found the bug for them, but I was probably trying to deploy something to production, so that's unfortunate. And in that case, the answer is obviously more tests. More tests, always. Okay, back into ancient history. This was a period back in 2011 where we open sourced Scala School. People were trying to figure out, obviously, for the entire history of Scala at Twitter, people have been trying to figure out functional and OO and precisely come down on what you want. But this is, we kind of incorporated some more functional programmers, and people were asking, well, how do we do type classes? I believe somebody recommended view bounds at that point, which now would be a terrible idea. So, and internally, the question continues. I think what we've found, though, is that many patterns are just ruled out by the focus on immutability, because immutability is something that almost everyone agrees on, unless you're in very performance-critical code. You are the 1%. In terms of performance. And so when you use immutability, a whole bunch of different patterns are ruled out. Builder pattern is great for immutable structures, so it's one of them. Also in this period was the first suggestion of switching to pants away from SPT. We were in a monorepo at this point, the birdcage, and but SPT was being used with these source step plugins to build nearby code. But neither SPT nor Maven were actually designed for source steps. They really are assuming there are artifacts going on. I think the situation has changed in SPT to some degree, and I think dbuild changes it entirely, which is very good. But in any case, at this point, Pants was maturing, and people were a little bit annoyed with using a tool that hadn't been designed for source dependencies. But nothing really happens there for a while. So I didn't put the prefix on here, but this was also a period in which tail call elimination was added to our internal future because people wanted to write loops, as one does. So this was the first instance of, or this is when tail call elimination began to exist. This is also when scalding got its start. Anyone use scalding? Oh, okay. A few folks, good. Yep, and it was open sourced only a little while afterward. Okay, so now getting into the 2.9 days. Related again to that tail call optimization, Marius Eriksson is kind of the head Scala guru at Twitter. And during this period, he commented on the SIP14, which was the Futures and Promises for Scala proposal. So current status is ComTwitter util future and Scala util future are still independent. I think based on what you'll see of Twitter's history of tooling changes and things like that, and finally reaching some stability, I think it's possible that we will finally be able to unify those. But in particular, one thing he mentioned during this proposal was without tail call elimination, you might run into some issues. This is also when Effective Scala was open sourced. And as I said, we were moving away from SPT toward Maven. It was not a huge improvement. I think it was because a lot of people that were coming in, we were acquiring a lot of companies, and we were getting a lot of new hires that were familiar with Maven. And unfortunately, that was the reason for that particular change. Lateral, more of a lateral change than a guaranteed improvement. This is when Scala 2.9 was released. So upgrading to Scala 2.9 was during a Yak Day. So the org was still small enough to get everyone in a room. I think there were 12 or 14 people that were enough to unblock upgrading the whole company. But unfortunately, it occurred during the switch to Maven, meaning that we lost support for cross-publishing, so there was a little bit of head-scratching there. But eventually, it ended up being major version bumps. So this was sort of halfway through many projects import into the monorepos. And so you still had many cases where either leaf projects or internal nodes in the graph were sitting out in GitHub repos. So you had to find them, and you'd kind of be like, oh, okay, I'm making a lot of progress. I'm in the birdcage repo. I've edited a few projects. Oh, shoot, one of them lives outside. Well, that really sucks. We should fix that. And so during this upgrade, many things were sucked into the monorepo. And we have done some work ourselves to improve the Maven and Scala support in IntelliJ, but the community has brought everything else to the table, so thank you. During this period, we also had a huge onboarding of Twitter devs to Scala because the Scala services and the monorepo, or the monorail, excuse me, the monorail had been coexisting for a long time, and it was time to just kind of call it quits on the monorail. We're still in the long tail of killing the Ruby monorail, but during this period, the efforts kind of kicked into high gear, and there were a lot of internal courses to get people developing Scala, and a big activity of our internal lists, lots of newbies. So bijection was released in this period, Scala 293. I think this first point was actually in order to get Twitter more aligned with Scala util future, in the sense that the await pattern is common there. So this was a very large cross-cutting action to deprecate, get, and apply on com Twitter util future. And again, it was huge because it was being used absolutely everywhere. Also in this period, something called Stitch was created. And Stitch is a library, a Stitch object is like a future. It's not open source yet, but I think it's in the pipeline. A Stitch object is like a future, except it's executed lazily, which means you can do things like, if I'm making requests to a Thrift API that returns data, I can build up a series of those and then execute them afterward, at which point I can implement batching and various different strategies around deduping the number of requests that go to the server. So very useful, but more of a building block. Now in the Scala 210 period, these SPT and Maven and Pants transitions make zero sense, and I can't possibly add enough context to explain them. But I would say that this transition was a big relief for a lot of people, because neither SPT or Maven were great fits for building from source. But our upgrade to 210 was initially blocked on being on Pants. During this period, Summingbird was open sourced. Summingbird is great. You should check that out as well. So in April 2014, the rumblings around Scala 210 amplified, and the upgrade really started in earnest in May 2014, and then it landed in September. This doesn't sound like a great pitch for monorepos, though, right? This took months and months and months. Part of the reason for that, and the largest reason, was that the repos were not completely stitched together. We had two sides, basically, the birdcage and science sides, and a huge amount of publishing needed to happen. So the upshot of this is that it took 2 people something like 3 months, and then followed by 1 month of effort by the entire company to get upgraded. And that was kind of the birth of a framework for large cross-org projects. So what we have are these wide branches when you need to change everything. So if I need to change, for example, the Scala version, or I need to change the build tool, or I need to change anything, the model is to branch and have some core team of, which will be a very small fraction of the entire company, do 90% of the work, right? They're the moon landing, the initial folks, the pioneers. They do the work, they create a FAQ, and then they farm out the remainder, the long tail of work, to the teams. And you land any backwards compatible changes in master, you do the rest on the branch. And as an example, the 210 upgrade went that way. So it was a very small group of two or three people who figured out all of the edge cases and figured out all of the gotchas before anyone else got involved. But then everyone got involved during this last month. So the upsides of these wide branches are you have the focused expertise, you have a core group that assists everyone else. There's relatively low overhead because rather than requiring many thousands of branches, one per project or anything like that, you have a single branch. But also, if this is a change, unlike a Scala version bump, but like an API change, if I wanted to make some change to the semantic system code that I can't trivially just rewrite, I learned very quickly whether the change is a bad idea. So in a version-based world, if I'm going from 2 to 3, and I haven't actually tested out the code on anyone, I might make completely the wrong decision. I might, and the example I always use is Hadoop MapRead and MapReduce APIs. They launched this brand new replacement API without really having dogfooded it on anyone, and so rather than flocking to the new API, people were like, well, I'm kind of lukewarm on this, so I'll just stay where I am. And so it's critical that you learn as quickly as possible whether a change you're making is a good idea or a bad idea. And this kind of concentrated effort to decide whether something's worthwhile really helps with that. But the downsides are, again, that if you try to do this really tightly, you have a lot of coordination. It's kind of like, okay, for the next week, I'm saying the entire company needs to work on something. And you can land a branch really quickly that way, but they were probably working on something critical in the meantime. On the other end, you can set up a branch so that you can maintain it for a long haul, but you end up doing more effort or doing a lot more work to make that happen. And you have to do many, many, many merges. If you haven't set up correctly to do a merge, that can be a big pain in the butt. So you try to find some, per change, you try to find a reasonable balance. Okay, back in the 210 era, Future had kind of peaked out. It's now in 1/3 of all Scala files, imported in 1/3 of all Scala files. And scalding is actually our internal default for analytics jobs. We had a lot of investment in Apache Pig, but that has been completely deprecated. No new jobs are being written there, and all existing jobs are being ported to scalding. So scalding, like we don't really have any usage of direct usage of Spark internally, but it seems that the most likely path is that scalding will get a Spark backend at some point. And then it'll kind of be a flip the switch day. Suddenly, scalding is using Spark. Scala 2.11 was also released during this period. So we are not yet on 2.11. That's coming up this summer. During this period, Pants got isolated compilation. Before, it was doing batching. And this is critical because it actually lines Twitter up again to be good community members, at least with regards to build tools. Pants uses Zinc, which uses SPT directly, and now we are just like any other SPT project except via an API. Except also that we are going to have something like 900 targets/projects per build. Also, we are now using Zinc to compile our Java code as well. And we immediately found 2 or 3 bugs that have probably existed for ages and ages in there. So that was good. Patches coming soon. So I think the moral of this story is that 95% of cases, Twitter's issues, if you run through there, it's probably even more so the case. Twitter's issues with Scala have in fact been tooling issues. And our current focus is entirely on improving tooling. We've reached a very sweet spot, and I think the next few months are going to be very interesting indeed. Continuing story of what we want from Twitter, or from Scala, excuse me. We kind of have a constant desire for less object overhead, as everyone does. If you can use an idiomatic API and have it not cost you an arm and a leg, that's great, which is why the Dotty linker optimizer talk is probably very cool. I think we're all going to watch that on video. We have many binaries that go out that are 600 to 800 megabytes worth of jars. And so if you can do dead code elimination on that, I think the results would be spectacular. We would love improved support. We know TypeSafe is working on Abide for maintaining consistent code bases. And we will be upgrading to 2.11 this summer because all of this repo merging will finally have been completed in the next week or two. Meaning that upgrading to 2.11 is actually making edits in 2 or 3 places, and then sandboxing it and seeing whether it compiles or not. In libraries, we are not using the async macro anywhere, but I think that's something that we should absolutely be exploring, considering how much future usage we have. And anyone who's worked in data modeling has an interest in something like Shapeless's HList for type-safe records, so it feels like that should be something in the standard library. We'd love that. Also, we're not using Scala on any other platforms, but of course there is code being developed on these other platforms, and so in order to dedupe and allow for more sharing, we'd love to be deployed on these other platforms. And in tooling, we're going to continue to drop the overhead that Pants has for incremental compiles to as close to 0 as we can. Pants itself does not have its own server, and so on startup it does a little bit of hashing, and there's a little bit of overhead in addition to whatever overhead the SPT incremental compile introduces. Also, SPT server is very interesting for us because we're currently using Zinc, and Zinc is deprecated. Also because the server promises to do its own hashing beforehand, which will help us. And we would love large-scale refactoring tools in general. We're building a knowledge base of folks who are familiar with writing compiler plugins, and that will hopefully allow for something that we can eventually open source for automating more of these wide branch upgrades. And so, do I have multiple copies of this? Yes, I think I do. So the gist of this, though, is that we are really interested in whatever the Scala community can bring, because we are now at a place, tooling-wise, where we're able to consume it quickly. This 2.11 upgrade should take on the order of a month. The 2.12 upgrade should take a similar amount of time. But it will just be whenever we decide to do it. It won't have a huge long tail of things that need to be published. Okay, so Twitter is definitely hiring for, obviously, Scala developers, but also people intimately familiar with Scala who are interested in working on the build tools. It's definitely never been a better time to work at Twitter on this code. So thanks to all the early Scala adopters. These are Twitter folk in no particular order. And who has questions?
Hey.
Hi.
I have one question regarding the monorepo. You basically explained the advantages of basically being able to make a change in a producer and a consumer in one single atomic step. I'm wondering how you map that to the deployment stage, because I can imagine if those changes in the producer and the consumer end up in different services, you would theoretically need to make a synchronous deployment to make sure that both upgraded versions end up being run in production. How do you deal with that?
Yeah, absolutely. So we use a lot of thrift internally, and thrift is it's not my favorite, but it allows for backwards compatible service changes. It's, for those who haven't used it, it's a DML that you use to define an interface, and then there are rules about how you can change that DML and remain backwards compatible. So yeah, if two services are publishing and consuming particular thrift interface, you change them backwards compatibly, or you know who your consumers are. Any other questions? Cool. Well, thank you very. Oh, one more.
If I understand well, you mentioned that you weren't going to use Git, or you are not happy with Git and you're going to replace it for something else for some reasons?
Yeah, maybe. We'll see. Git is fantastic for small projects, but it's written using the file system as a database, which, particularly on OS X, is not the best choice. Things will be orders of magnitude faster on Linux than they are on OS X with regard to file system operations. And particularly with a repo of our size, Git has slowed down quite a bit. So we have a group of people working on it. It's possible we'll stick with it, but it's also possible that we will explore other options. So I shouldn't speak too soon there.
Hey, so assuming that someone is starting a new project and wants to go for monorepos, how would you recommend implementing that? Like, is it an approach that needs a lot of tooling to be built around to not blow up the times of compilation or something like that? Or is it something that you can use out of the box?
So the three monorepo specific build tools that I mentioned are all open source. And Bazel is Google's open sourcing of Blaze. It does not contain everything. It also doesn't have Scala support, so there's that. But maybe that's not too difficult to add. But Buck and Pants are both open source as well. Pants, of course, has Scala support. We are at the point where we could use a few more Pants developers before we get a ton of Pants consumers. But we're on the cusp there. So if you are familiar with both Python and Scala, we would love to have you as a Pants consumer. But yeah, then you get the distributed build caching essentially out of the box. It has a plugin interface that hits whatever REST server you can put, or just like a varnish cache or something like that.
Okay, thanks.
But I think there's actually remarkably little tooling around source steps, because really it's how all projects start, and they grow you'll have the case where you have sub-projects within one repo, and at some point you have too many sub-projects, and who knows what happens there. But that doesn't actually require any additional tooling. All right. Well, thank you very much.